When wiring a fiberglass pool with a metal handrail, it's crucial to understand the proper grounding procedures. The focus is on the termination point of the number 8 grounding wire connected to the handrail. The other end of the number 8 wire must be connected to a dedicated circuit breaker within the main electrical panel. This circuit breaker should be rated for 20 amps. This serves a critical safety function, protecting the pool equipment and the pool itself from potential electrical overloads and short circuits. Now let's delve deeper into the specifics. Firstly, the selection of a 20 amp circuit breaker is important. It provides the appropriate level of protection for the grounding circuit. Secondly, the wire itself must be run within a conduit or a raceway. This conduit serves several purposes. 1. It physically protects the wire from damage, whether from accidental impact or general wear and tear. 2. It shields the wire from exposure to the elements such as rain, sunlight, and temperature fluctuations, which can degrade the insulation over time. Considering the environment around a pool, the importance of proper protection cannot be overstated. Direct burial of the wire without conduit is not recommended and may violate local electrical codes. The grounding wire needs to be a solid copper conductor of at least number 8 American wire gauge. The wire needs to be green or green with a yellow stripe in order to be recognized as a grounding wire. The National Electrical Code, or NEC, provides specific guidelines for the installation of grounding and bonding systems for swimming pools. Consult the latest edition of the NEC and local electrical codes to ensure compliance. Thirdly, when connecting the wire to the circuit breaker, ensure a secure and proper connection. Use a terminal connector that is appropriately sized for the number 8 wire. Tighten the terminal screws to the manufacturer's specified torque to ensure a reliable connection. Loose connections can create resistance, leading to heat buildup and potential fire hazards. Fourthly, the conduit should be properly supported and secured along its run. Use appropriate clamps or straps to attach the conduit to the building structure or other support surfaces. The spacing between supports should comply with the NEC and local codes to prevent sagging or damage to the conduit. The type of conduit selected should be suitable for the environment. Rigid metal conduit, intermediate metal conduit, or PVC conduit are common choices. The selection depends on factors such as corrosion resistance, mechanical strength, and cost. Firstly, when routing the conduit, avoid sharp bends or kinks that could damage the wire or make it difficult to pull the wire through. Use conduit elbows or bending tools to create smooth, gradual bends. The radius of the bend should comply with the NEC requirements to prevent damage to the insulation of the wire. Secondly, ensure that the conduit is properly grounded. If using metal conduit, bond it to the grounding system using appropriate bonding connectors and jumpers. This helps to create a low impedance ground path, which is essential for safety. Thirdly, before energizing the circuit, test the grounding system to ensure its integrity. Use a ground impedance tester to measure the resistance of the ground path. The resistance should be low enough to ensure that the circuit breaker will trip quickly in the event of a fault. Fourthly, label the circuit breaker in the main electrical panel to clearly identify it as the grounding circuit for the pool handrail. This will help prevent accidental disconnection or misidentification in the future. Now let's talk about the handrail itself. The connection to the metal handrail should be made using a listed and labeled bonding connector. This connector should be suitable for direct burial if the connection is located below grade. Clean the surface of the handrail where the connection will be made to ensure a good electrical contact. Remove any paint, rust, or other contaminants that could interfere with the connection. The bonding connector should be installed in accordance with the manufacturer's instructions. Tighten the connector screws to the specified torque to ensure a secure and reliable connection. The NEC also requires bonding of other metal parts of the pool, such as the pool water, the pool pump motor, and any metal fittings or accessories. This bonding helps to equalize the electrical potential of these metal parts, reducing the risk of electric shock. Follow the NEC guidelines for bonding these metal parts, using appropriate bonding connectors and jumpers. The grounding and bonding system should be inspected and tested periodically to ensure its continued integrity. This inspection should be performed by a qualified electrician. The inspection should include a visual examination of the wiring, conduit, and connections, as well as electrical testing to verify the continuity and impedance of the grounding system. Any deficiencies or problems should be corrected promptly to maintain the safety of the pool. Remember, electricity and water can be a dangerous combination. Always take precautions to protect yourself and others from electric shock. If you are not comfortable working with electricity, hire a qualified electrician to perform the work. Follow all applicable electrical codes and safety regulations. Firstly, always turn off the power to the circuit before working on any electrical components. Use a voltage tester to verify that the power is off. Secondly, wear appropriate personal protective equipment, such as rubber gloves and safety glasses. Thirdly, never work on electrical equipment in wet or damp conditions. Fourthly, do not overload electrical circuits or use extension cords as permanent wiring. Fifthly, keep electrical equipment and wiring in good repair. Replace any damaged or worn components. Sixthly, if you experience any electrical shocks or unusual electrical problems, turn off the power immediately and call a qualified electrician. When it comes to grounding and bonding swimming pools, there are several common mistakes that should be avoided. Firstly, failing to properly bond all metal parts of the pool. This can create a potential difference between metal parts, which can lead to electric shock. Secondly, using undersized grounding or bonding conductors. The conductors must be sized according to the NEC requirements to ensure that they can carry the fault current. Thirdly, making improper connections. Loose or corroded connections can create resistance, which can lead to heat buildup and potential fire hazards. Fourthly, failing to protect the wiring from damage. The wiring should be installed in conduit or raceway to protect it from physical damage and the elements. Fifthly, neglecting to inspect and test the grounding system regularly. The grounding system should be inspected and tested periodically to ensure its continued integrity. In addition to the NEC, there may be local electrical codes or regulations that apply to swimming pools. Check with your local building department or electrical inspector to determine the applicable requirements. These codes may specify additional requirements for grounding, bonding, or other electrical safety measures. It is important to comply with all applicable codes to ensure the safety of the pool and its users. Grounding and bonding are essential components of a safe swimming pool electrical system. By following the NEC guidelines and local electrical codes, you can minimize the risk of electric shock and ensure the safety of the pool and its users. Always consult with a qualified electrician if you have any questions or concerns about electrical safety. Remember that the 20 amp circuit breaker serves as a crucial safety measure. It is designed to trip or disconnect the power in the event of an overload or short circuit. This prevents excessive current from flowing through the wiring and potentially causing a fire or electric shock. The selection of the correct size circuit breaker is therefore very important. A circuit breaker that is too small may trip unnecessarily, while a circuit breaker that is too large may not provide adequate protection. 20 amp rating is typically specified for this type of application to provide a balance between protection and performance. When installing the conduit, ensure that it is properly sealed to prevent water from entering. Water can damage the wiring and create a path for electrical current to flow, which can be dangerous. Use waterproof connectors and sealant to seal the conduit fittings. Also, consider the location of the pool equipment when planning the wiring. The equipment should be located in a well-ventilated area that is protected from the elements. This will help to prolong the life of the equipment and reduce the risk of electrical problems. If the pool equipment is located outdoors, it should be installed in a weatherproof enclosure to protect it from rain, snow, and sunlight. This enclosure should be properly grounded and bonded to the grounding system. In summary, correctly terminating the number 8 grounding wire to 20 amp circuit breaker in the main panel within a protective conduit is paramount for the safe operation of your fiberglass pool. By adhering to these guidelines and consulting with qualified professionals, you can ensure a safe and enjoyable swimming pool experience.